Okay, so what we're going to do is follow the tutorial at this link, which is right here. Although, I don't know, this is gently inspired a little tiny bit by this tutorial, but I won't follow it too closely. But it's a good tutorial to look at and explains many things in great detail with lots of links and big tables of stuff like this, which is useful to look at. I'm just going to give you more background and context. So first, I'm importing, and I will use these throughout the rest of this tutorial. I'm importing NumPy as NP, just like we did on Wednesday, pretty standard thing to do. And I'm importing a library from Matplotlib called Pyplot as PLT. And just to emphasize, Matplotlib itself is a very mature, large, sophisticated, nicely object-oriented base layer for doing plotting of 2D graphics in many systems, such as Sage. And this thing, Pyplot, it's just a library inside of Matplotlib that provides a MATLAB-like API to Matplotlib. But there are many other ways that Matplotlib gets used. Okay, so so when I show you this, don't think, oh my God, Matplotlib has the worst ever API imaginable. It's really MATLAB that does. Although, so I want to emphasize, depending on what you're doing, you may think that MATLAB and or Matplotlib have an awesome API or a horrible one. It really depends on the type of problems you're solving. Okay, so let's get started. So here's a basic example of using Pylab plot function. This function is completely different than the plot function you've been using already in Sage, although it accomplishes pretty much the same thing. Instead of giving it a function or something callable as the first input, and then it evaluating that function at lots of points and drawing a plot, instead you give it a list or a one-dimensional NumPy array, and what it will do is it will draw points. It'll draw a line that goes through 0, comma the first number, 1, comma the second number, 2, comma the third number, and so on. This is kind of the first way to use it, at least. I'm going to zoom out a little so you can see the whole plot. So notice that it went through 2, comma 3, and then it went through 3, comma 10. So it drew a line, or a sequence of line segments that go through the points that have these as the y coordinates, and the x coordinates are 0, 1, 2, and 3. So that's the most basic way to use the plot command. Obviously, in and of itself, that wouldn't be so useful. There's a second argument you can provide, which gives what the x values should be. So instead of them being 0, 1, 2, 3, etc., you can do this. However, just to give you a sense of how this might be useful, remember you could do numpy.array. Let's say we want to make the numbers from 0 to 10. What would we put here? It's arange, sorry, arange. This gives us the numpy array of numbers from 0 to 10. And let's say we wanted the signs of all of these numbers. What would we do? Yeah, almost np.sign. That gives us the signs of all those numbers. Okay? And now watch, if I do plt.plot np.sign of np.arange, I messed up, seen it, and then do plt.show, I get a beautiful plot of the sign function. Woohoo! Okay? But you see it does look like the sign function. And if I did it with a bigger value, like 30, it would be the sign function from 0 to 30. So, okay, that's really bad, but don't worry, it's fixable. Yes, you have a question?
I'm just kind of wondering about the semantics, like why is it, so is there a plot object that's showing itself? Or like
there's a single figure that gets created, and you can do all kinds of manipulations of it by calling various plot functions. And when you do .show, it prints out the figure and then clears it. So that's what's going on here. You could do it you could do like one plot, plt.plot, and then in a completely different cell. So you do this first. Then you could do another thing with, say, cosine. And then you, in a sense, show the figure. It's kind of like you print out the result of doing all these things. What the hell? That doesn't work. I don't know why that doesn't work. Oh, okay. That should print out the combination of these two. Doesn't. Could. Puzzled. This may be a bug caused by how some stuff I do to make this more, maybe due to my misunderstandings of things. Let me do it all in one cell to avoid any issue with that. So this is what I was trying to illustrate. You do a plot, and it writes something on that figure. I think when you do a new cell, it resets the whole figure. So at least in Sage Math Cloud's worksheets. Possibly that's a mistake. But in any case, that's what it does. So you can just keep drawing plots. Notice that so this is very different than how it works in Sage. In Sage, if you want to have two plots on top of each other, you draw them and you define them and you use plus to superimpose them. And also in Sage, the color of the plot won't change just because you make another plot. Like the default is blue and it stays blue every time. So it's very different here. But if you were to type that code without the PLTs and NPs in front of it into MATLAB, it would do exactly the same thing. You get a frame, you get something that looks just like that. So this is very, very inspired by MATLAB. Okay, so it's a very different model where you have this kind of canvas or this figure, and you're mutating it by calling various commands, and then everything's getting sort of accumulated there, and then you say .show, and it just displays it. Okay. So let me just tell you how to actually do something useful. What you do is, in addition to giving the y values and having the x values just default to 0, 1, 2, 3, you can explicitly say what you want the x values to be. So here, I've made the x values 0, 2, 4, and 6, and that's why there's dots at 0, 2, 4. Sorry. No, the y values are 0, 2, 4, and 6, and the x values are 1, 2, 3, 10 now. Yeah, so wait. Yep, okay, so that's kind of confusing, but that's the way it is. And everything I'm saying is consistent. But if you give two lists, then the first list gives the x coordinates, and the second list gives the y values. X before y. But if you only give one list, you're only giving the y values. Okay, so now how could this be really useful? Watch. And this does actually look pretty nice. So let's just go back to our example above of sine. Let's try to make this nice and smooth. So on Wednesday, we learned about np.linspace. You can give a range, let's say the range from 1 to 10, and then you could say, I'd like to have a point at every interval of point, say, 0.5. And then you'll get back something that has numbers from 1 all the way up to 10 incremented by 0.05. So now instead of sine of this, we'll do it like this. Now we'll put x and then np sine of x comma np cosine of x. When I hit enter, we should see a plot of sine and a plot of cosine, and it should look really nice and smooth. Okay? And it doesn't. What the? Did I use linspace? Oh, linspace doesn't take the size, it takes the number of sample points. So I think 0.05 sample points is like 0 sample points or 1 sample points. So I should really say, oh, I want 200 sample points. Now let's try it. There we are. Boom. So now, see how this is just very, very different than the Sage plotting you've used. But it isn't necessarily, like I told you, you may love or hate it, but it isn't necessarily bad at all. It's actually, in some ways, kind of really awesome. You have x, you say it's exactly the numbers from 1 to 10, and a whole bunch of exactly 200 samples between 1 and 10 inclusive. And now plot and make the x values be exactly those numbers. And then the y values are what you get by applying this sort of transformation to that array. And you get back applying sine to all of them. Okay? And there's other things you can do, like if you do x times 2, so x to the power of 2, it'll go through the numpy array and square all of the entries. And so you'll end up with sine of x plus x squared. That's what this plot is. So it's actually a super, very, very data-oriented way of thinking about constructing plots. Completely, it's like you take what you do in Sage, and Sage is almost exactly like Mathematica, by the way, for 2D plotting. And you just kind of like, I mean, it's just like you turn everything sideways. It's like you transpose your entire perspective. You just flip everything inside out. And it's like the difference between, I don't know, pure math people and applied math people or statisticians. So one is actually way better for certain types of things, and the other is way better for certain types of things. So it's really cool that you have both available when you use Python. Okay, so there you are. You can kind of see how this works. And then there's just a bunch of other things you can do. Like, instead of giving a whole bunch of separate plot commands, you can give the x and y values, and then just give x and y values again and again, and it puts them all in the same plot. You can also specify things like the color and the and line styles and stuff very efficiently. So here's an example of that. So say you want to make the line red, and you want to have little circles at each of the points where you're plotting, and you also want to have a line there. So that's what this RO dash thing means. RO dash is right there. That's some like little string, and it means make the line red, put little circles there, and make a solid line through it. Make a bunch of dots and put a solid line through it. This is something that's exactly like what you'd have in MATLAB. And so like once you get used to it, you can be super efficient at very quickly drawing plots that look nice. Okay? Just to give you some connection with Sage, if you wanted to draw that same plot that I had above using Sage, using the plot commands in Sage, there's a line command which takes as input a list of points, x comma y, and then draws a sort of sequence of line segments that go through those points. And you can say what the color of the line is. You can put a marker at each of the points. And the zip command, this is something built into Python. It takes two lists or iterables and then iterates through them and makes the list of pairs. So like it takes the 0th entries, the 1 entries, the 2 entries. I want to bite my tongue saying that stuff. And ends up with a list of pairs. So you might not have seen zip before, but it'll save you some time. Look, see? It just zips together two lists. The 1 and the 0 go here. The 2 and the 2 go here. The 3 and the 4 go here. And the 10 and the 6 go here. And I'm now seriously curious if this works with three things. I have no idea if this works. It does work. Yay. Okay. But we don't need that. And then another thing is frame equals true. So normally when you plot in Sage, it draws XY axes. And you can do frame equals true, and instead it'll draw a frame around your plot. So this thing of defaulting to having XY axes versus defaulting to having a frame is, again, one of the differences that you'll see between, say, MATLAB and Mathematica, or between Matplotlib and Sage. Okay, here's an example with two curves. I already showed you that above. And just for comparison, here is what you get if you Google plot MATLAB. And you'll find that this is MATLAB's official documentation. Notice that they have a plot command. It takes as input a MATLAB array, or a one-dimensional MATLAB array, x and y, and then some possible spec that draws it in a certain way. And their first example right here, so that makes a bunch of values between 0 and pi over 100, and y is the result of applying sine to all those values, and then you plot it. So MATLAB is very similar to Matplotlib. They're not identical, but they're similar. Okay. So guess what this will do? So here's the code. What do you think this is going to do? So first, what do you think that line does? np.arange 05.2. What am I going to see when I print this out? Yeah.
An array from 0 to 5 in increments of 0.2.
Yep, exactly. It's not lint space, which would give me 0.2 values between 0 and 5, which is stupid. It's NP A range, which gives exactly what you said. And numbers from 0 to not including 5 incremented by 0.2. Okay, now what is the next line going to do? Like, just the beginning part. So that's going to draw a line, straight line, because I made the x and y values both exactly these same numbers. And then something happens here. Maybe you don't really know, but it's going to be red, right? So, and then you can give multiple inputs without having to separately call plot over and over again. And that's what we're doing here. So the second thing is going to draw the plot of y equals x squared. So a parabola. The third thing will draw y equals x cubed. And this one will be B, maybe that's black, maybe it's blue, I don't know. And this will make something green. I don't know what the S does, but let's just see. Okay, so looks like BS is like little blocks that are blue. Probably S is for square, so blue squares. And then these are green triangles. Okay? Okay, another one. What's this going to do? Should be easy now. Using the same T as above. What kind of plot will this produce? You have to kind of guess because I haven't mentioned what line width does. So should be pretty obvious though. This one's ridiculously easy. Yes?
Can I give you a green plot with P cubed plus T with, depending on the default, either a thinner or thicker line?
Yep, exactly. And I think the default's 1, so it should be thicker. And here we are, exactly what you said. And it goes from 0 to 5, or 1 to, yeah, 0 to 5, because that's how we define T in the first place. Awesome. Okay, so here's an exercise which you should do. And it should be pretty easy given just like the 2 or 3 things above. Okay? So go ahead and do this exercise.
So why would the green line, how's it drawn so precisely when we have before we have to specify? Is this plot like next points? Where are you drawn?
Just do NP dot. Simplify float approximation. So what is x? Maybe you could print out x. You can use solid for print out x at the top. I'm guessing you didn't set x equal to np dot a range.
Oh.
Maybe put it increment by smaller intervals.
Oh wait, okay, I see. It was there. Okay, so that's why it's
Good job. That's going to work perfectly. But then this one you need to set you need to make x equal np dot a range. use arrange or then space. Yes.
We have two different and you have to do
boundaries.
We put space. So,
I mean, the boundaries are the boundaries for the graph.
so if you're doing you need to say X.
Probably.
Yeah.
It yields it down.
Is that just what you did the
One is not behind.
Maybe you didn't say you should have remembered class. So try that.
Oh, no, sorry, what?
And that was like applies to the.
Oh, I'm just.
Oh, what's that?
There was a nightmare last night. It's
So
fixed
you
this
messed up.
morning. It is saying.
Oh, okay.
And until like 3 a.m. It just wouldn't render error set. It's fine this morning.
Ah.
And worse than that.
What would happen?
It said it had a problem rendering the character set or something.
Oh.
And like for several hours, like every histogram plot was broken. It was also like, now it's working.
Well, so with it, I don't know what stage that comes in, but restarting a worksheet will possibly be because like there's a Python process behind the scenes and they can get all kinds of weird state. So that could have been the problem. And if you wait 1 hour, it will kill all processes of the linear computer.
I think I was working straight on it.
Yeah.
So it was not to the character.
Yeah, so it's possible to arbitrarily mess up the state of that Python process. So things can be pretty confusing, but clicking restart will completely kill that process.
And
And
then
start
we
again.
restart the whole thing.
Yeah, that's a good thing to do.
I think I messed with the settings a bit.
Yeah.
And script the character map, so
That's
nothing's
totally
rendered.
doable. And then you can try this out. And the project itself is a restart. So that's essentially this. You just restart the project. Like every process. Oh, there's a new thing right here, which is a little put there.
Isn't it?
Oh yeah, I saw that. We should ask rather than somebody up it. Although that helped me just until 1 hour ago.
Okay. It seemed to, it definitely saved it.
Yeah, it was. Any questions?
You first? How do you feel? Yeah, how's it going? Oh,
We didn't cover it. We went to him.
you got Marvel's fair.
Oh. Wait, so Sunday?
Yeah.
That's weird.
I mean, you're confused.
You're asking
Like, I want to hang out, but like,
I'm not for
cool.
it.
Like, we went to just.
You did a double.
Yeah. But it was like, and I like, I was.
Really?
Not that big, big as well. But like, there was.
So the lowercase x is symbolic.
That being some very double. That's weird.
Matplotlib.
It's not a bad thing, it's just like, they're very different.
It's just like very noticeable.
Yeah, so there's three.
So if you make sure you just
I
change
realize
every
opposites
single
attract, but no one says what the other is. So
who's going to be there?
So
Or
then,
alternatively, you let lowercase x in there.
but they're doing it.
So
And it's like,
can't be any better.
it's like, it's the same for
yeah. And then mom's more laid back.
well, yeah, I mean, yeah.
Is a stepmom much similar now?
She's chill. She's very, like, energetic. But his dad is
I think this is.
Very like.
yeah, like, yeah, no,
Yeah.
like,
Oh, and not like.
not metaphorically.
Get your ass.
No, like, in a really nice way, but like,
Plot context. Do I have to change it to an annotate function, or is there something that I can get like a good up top? Oh, you haven't done this, have you?
no,
I would think of switching.
Oh, well, if you
don't
don't
like
like
the scale. Yeah, no, for plot context. I want the
I always think like an
that
annotated
can
title.
He's not
cautious
social
the
science.
nature every time I go through try to replace base color with I set it up here. But I mean it is something called, I don't know if I'm just doing this wrong. So yeah, so basically so what works is this. I'm able to do this and put it in, and then as soon as I try to speed it out,
Nice. That looks great. All right, so I'm going to show you a little bit about how to make figures, and then we'll just do homework for the rest of the time. So this is a nice solution to that problem. Not too bad. Okay, so the last thing that, and thanks to everybody else drawing their plots of polynomials. Wow, there's a lot of them here. Okay, so the last thing I'll show you briefly is figures. And here it is. So this is just an example of creating a plot and another plot. But the cool thing is that when you look at them, you see two plots in the same image, one on top of the other. Okay? And the way this works is you can say subplot, and then you give 3 integers between apparently 1 and 9. And the integers, okay, since people keep working on this worksheet, I will switch to my own worksheet. So the integers give you the number of rows and columns. So this is all one single figure. And when you say plot.subplot 211, sorry, this is really tiny. When you say plot.subplot plt.subplot 211, it says now my figure is going to have 2 rows, 1 column, and I'm now going to draw figure number 1 in there. And then when you say plot.subplot 212, suddenly it switches to drawing figure number 2 in your 2x1 grid. And then when you do show, it shows this 2x1 grid. If you wanted to have a 2x2 grid, which is the exercise I put in there, you could put 2, 2 like this. And then you're putting your various figures in a 2x2 grid. So now if I run this code, now I get a 2x2 grid. Okay? So you can see how this could be useful. I mean, I have to admit that I find this just disturbing. I mean, isn't this crazy? You literally like set your stuff in a grid by putting these funny 3-digit integers whose digits are interpreted as telling you the size of the grid and which figure you're using. So it's totally insane, but that's what it is. But it looks great at the end. I just have to tell you, in Sage, there's a graphics array command. You give it some plots that you've created or arbitrary figures that have anything in them, and then you just give a list of lists, and it lays them out in a nice grid. Makes a lot more sense to me. So like here's a 2x2 grid. If I wanted to make this is a 2x1 grid. If I wanted a, say, 2x3 grid, I would just put two rows that have 3 things in each of them. And as you should see in a moment, it should give me a 2x3 grid. Okay? So that's how you do it in Sage and or Mathematica. Sage just copies Mathematica's graphics array command. It works the same as in Mathematica. Okay, so I just did that exercise basically. All right, so I just wanted to show you that you can make these sort of layouts and this whole subplot, etc. business. Pyplot, Matplotlib, or MATLAB, they're doing it automatically with just a 1x1 grid and 1 figure by default, but you can also make 2, 3 big arrays of images and plots. Okay, so we now still have about 14 minutes left, so I'll just continue walking around answering questions about homework. You can look at the rest of this worksheet if you want, and then you could also look at the worksheet from Wednesday, which I didn't completely go over.